Let's move on to the next testing method, ultrasonic testing. The principle of this method is that excess pressure is created inside the heat exchanger when checking for gas leaks, or a vacuum is created when searching for micro cracks on the casing. To detect leaks, an ultrasonic leak detector is used, also known as an acoustic detector. The operator directs the sensor toward potential leak locations such as joints, seals, and welds. If there is microdamage, the device detects surface irregularities. The ultrasonic wave reflects differently when the surface is not intact. When a leak is detected, the device produces both an audible and visual signal. The exact location of the defect can then be identified. This means that the defect can be located during an external inspection of the heat exchanger. The advantages of this method include that it is non-contact, meaning it does not require depressurizing the heat exchanger. It also offers high accuracy, detecting leaks in the range of 10 to the power of -6. Another advantage is that it can be applied to all types of heat exchangers, meaning testing can be performed with various gases and liquids. It is also safe and environmentally friendly, as it does not require the use of dyes or any chemical reagents. However, there are also some disadvantages. The method is highly dependent on environmental conditions. For example, in noisy environments, the device may produce false readings, so the test should be carried out in a quiet area. Operator skills are required. Proper device calibration and correct interpretation of the signals demand experience. It also does not always detect leaks in stationary liquids. In other words, the method works better with gases.
Well, I've encountered ultrasound many times in my life, mostly in the context of examining internal organs, so the basic principle is quite clear to me. Igor, could you share your knowledge on this topic? What have you learned about ultrasonic methods used for testing heat exchangers? As I understand it, this ultrasonic method also requires interpretation, similar to medical ultrasound, where a specialist interprets the information received from the device. From your experience, how is this method applied in practice? And what would you say are its main advantages and disadvantages?
I haven't personally used this method in my own practice. Out of dozens of service providers I've spoken with, only one offered this type of testing. It is relatively inexpensive. As for interpreting the results, the interpretation is already built into the device itself, which directly indicates the presence of defects. However, the operator's qualification is still important. Usually, this test is performed by a service provider, so from that perspective, there are typically no issues. As for the accuracy of the method, I can only rely on statements from service providers. It is more accurate than the hydraulic test, for example, but less accurate than hydrogen or helium testing.
Thank you.